So we've been playing with quantum computing in the multiverse for about 17 weeks now, and in total, we've only been doing it for 24 hours, but it's pretty amazing.
Confused there.
Sorry. Well, it's because it's a multiverse, and the multiverse is confusing. So we're talking about quantum computing. What's the difference between quantum computing and classical computing, Scott?
I have no idea. You tell me.
Well, I will tell you that I'm so glad you asked. So the difference between quantum computing and classical computing is based on binary, which is ones and zeros, and quantum computing is based on qubits. So that means that the bits of data are ones and zeros, and sometimes both. And it uses the information in what's called a qubit, which is employing the tendency of quantum mechanics called superposition to do the computing. The hardware is really, really expensive, and there are some companies like Amazon and a company like that I am trying to use recently called IonQ that actually has a quantum computer, and you're able to access it through the cloud to build what are called quantum circuits. So I can't explain to you like a 5-year-old what a quantum circuit is, but we can go through tutorial. We have a video queued up here that I kind of want to go through. That I've been talking to Scott about GitHub stuff. We're just trying to play with quantum computing, which is a type of machine learning, basically.
Quantum computing's been around forever, but because of innovations in cloud, that's why you're able to use it now.
Absolutely.
Most companies, most individuals would not be able to build their own quantum computer, but rent as you go.
Well, yeah, and the theory of it happened. I think as the Large Hadron Collider did that photon thing in the mid '90s. So I was reading a bit more about quantum computing, and there is a fella that theorized how the quantum computer could work, and I believe it was invented in 1995. That means this is a very, very new technology, like extremely new, less than 30 years old new. So that's cool. So anyway, there is this person here. We're just sort of going to do a react video after I make ourselves scarce here. Whoop. So you can see that on the return feed, but can you hear it? Can you hear it? That's the question. Probably not, because I'm not streaming to you. One sec. I'm just gonna. Okay, so I'm just gonna play it. I will translate thing if anything gets missed. Oh, I could do. That should help.
Oh yeah, I do. Yeah, that'll help.
So this is only a 10-minute video.
Yeah. Holy crap! Look at what they're spending.
Wow, current monthly cost. This is how you get an Amazon Braket manager. Okay, we know how to do that.
Recently, you will find it here in the recently visited part, as you can see here, mine. Or you can also navigate to it from services, where you will find this quantum technologies option. And
quantum technologies under services.
Or you can just go directly into it here if you type the name in our search bar. And
yeah, I always just type.
Braket just with a K.
Yep, B-R-A-K. It's a misspelled bracket.
To the bracket or direct notation that is used to express in the written form the qubits, right? So,
qubits.
Qubits. Not to be confused with qbert.
This view with
qbert, yes.
tiles that represent each of the quantum machines that you will be able to access to Braket. So one of the advantages of Amazon Braket is it will provide you a single control pane to access different QPUs, different architectures of quantum processors.
So QPU, quantum processing unit. That's a That's a
Yeah.
new. It's a new one for me.
And currently
Yeah.
we have available D-Wave,
Makes sense though.
IonQ, or
Yeah.
Recursion, which can be useful for different use cases, but you will be able to experiment in all of them from a single platform through Amazon Braket on the AWS cloud. So let's go into the tiles so you can see some of the details that you will find there for each of the QPUs. I will navigate first into IonQ, and I want to show you a couple of relevant pieces of information. The first one is this device ARN, or Amazon Resource Name, which is the one you will be using in your code to indicate the QPU, the particular processor in which you want to execute your circuit. And I will go into much detail there when I show you a piece of code, just as a sample, where you will place this ARN. Then you will also find that each QPU is available from a different region in the AWS cloud. And this is relevant because when you go into the task section to check the results of the execution of your circuit, it is important that you are in the right region to check for those tasks. I will show you that later. The other
Great.
important piece of information is the
Yeah.
availability of
That's
each
good advice.
QPU,
Period.
because
Be right.
each
Be in the
of
right
them
region.
is available.
So you see this what she's saying. There's a certain availability. So outside of those times, it won't be available because they're probably working on it, right?
Available at the different
Oh,
times
there's specific times. It's not
with
just.
Yeah, it says right here. Like I don't know. This is 5 months ago, so pretty recent. But it says availability for IonQ is weekdays 1300 to 0200 UTC. So
Yeah, universal time code. The
here.
um, that's interesting.
yeah,
Very
so it's
interesting.
just something to bear in mind.
Yeah, I think it would tell you that though.
Yeah, it probably says that. Like we can look at it. We can
Yeah, yeah,
poke around it after we're done.
What is the
yeah,
See
window
if it's still
in
like
which
that.
those processors are actually available? It doesn't matter if you send your circuit to one of those when they are not available, because it will go into a queue. But it is important
Oh,
to
okay.
know that
Did you
when
catch
you
that?
send it,
I did
yes,
not.
So what she said was it's you can still do your programming if you do it at those times and then send it like run your program, but it'll just wind up going into a queue. It'll just queue up, and then once the time comes on at some point, it'll run your program.
Right.
during the availability window. And you will find also for each processor some information regarding its topology and some other metrics that might be useful when you configure your circuit, or when you create your code. That will depend on the architecture of each of the processors. But more or less, this is the type of information that you will find in each of the tiles here when you check the different devices. Then I will show you this notebooks option. It turns out that you can directly code in your own computer if you install locally the Braket SDK. But you also can use managed Jupyter notebooks on the AWS cloud to code and run your circuits. So in this option is where you will find the link to navigate to it. I mean, you can actually launch your managed notebook from here, but once you have it provisioned, you will be able to access it from the link here. And I will show you that.
So as we discovered yesterday when we were playing with it, she's saying to exactly what we were doing yesterday, where clicking that link will get you to the Jupyter interface, which is on the cloud.
Yeah,
Um,
and I think it said something that the Bracket SDK is pre-installed went with the Jupyter notebook, so all the code just works out. You don't need to add the SDK to it.
Yeah, and you only need to have the SDK if you are doing it on your local machine.
Yeah.
you will have available some set of predefined bracket examples, which are really useful if you are just starting your journey into learning about Amazon Bracket, because you will find there some code that will help you to understand how to program your quantum circuits and how to use the Amazon Bracket SDK. So I will get into the getting started folder to show you just briefly some of the examples. I will not go into the detail of the code, but I want to show you some parts of these notebooks, of this code that is based on the Braket SDK, which is a Python library. So
Yeah, so this is how I learned the best.
Yeah. So it is a Python library that we were talking about yesterday, right? And
Yeah.
this shows you. I don't know, like I presume you can make it. I don't know how to make it look like this, but this is what this is what I copied. Okay, so I actually in Bracket, I've like, just for viewers, I did do this in an actual Conda like Bracket Python that looked like this, except for the build a circuit notes here and here. But it worked. So I did get my counter. It shot back a different output than I got here, but it absolutely worked. So anyway, I'll let her continue speaking.
Some relevant information. Well, here, just this, for example, is a Bell circuit, which is an entangled state between two qubits, and I invite you to go into deeper detail separately to know more about this kind of circuits. But the important part here is this.
So did you catch what she just said there?
No.
Okay, so the type of circuit that you're making here is you're taking two qubits and putting them into an entangled state. That's what the simple Bell state is. I'm not sure why it's called that, but it, like she's saying, if you want to learn what that is, you can go search for that, because she's not talking about it.
What's it called again?
Simple Bell state. It says here, it says build a circuit, build a Bell state with two qubits, and then it doesn't explain it. It's basically just two qubits, the information type that the quantum computer uses. It's two of those going into an entangled state. So that's a really yeah, it's a simple circuit, and that's a really complicated thing is that I certainly can't explain here. And
we'll dive into that later.
Yeah, that'll be a totally different video, or we'll when we do our DevOps breaks, which is a series of videos that we're going to be working on soon. We'll dive into that.
This one, for example, would be executed in a local simulator. And again, this can be your own machine if you're using the local SDK, or the machine where the Jupyter notebook is running.
So yeah, she's saying that you can use a local simulator on your own computer. That's a simulator. Or you can use it on the machine. In this case, she's going to be working on the IonQ machine, where the Jupyter network is running. Or notebook, not network, notebook.
To send the circuit to the actual GPUs or to the managed simulators. And I will show you that in the other examples that I have here. For example, if I go into this one, where we are running a circuit on the managed simulators, you will see that we have here also a line here in the managed simulators section that refers to the device. And then there you will see the ARN of the device, which is the Amazon resource name that I was referring to before. And you just have to specify here to let Braket where you want your circuit to be executed. Another important thing is when you use the local simulator, the results will be shown to you immediately. But if you're using the managed simulators or the actual QPUs, your results will be stored in a default S3 bucket.
So basically, did you catch that? Okay, all right.
But the results go into an S3 bucket if you do it on the machine.
Yeah, so which you have to specify. So that example, when we're looking at the code, my bucket, Amazon Braket, Van Ados.
Oh, that's what I learned something this morning. I'll send you the documentation. Actually, I have it up on my other screen. I'll read it. Fill in your actual existing bucket name where the following example shows example bucket. This is code I'm looking at.
Yeah.
And it says, this is the important part. Bucket names for Amazon brackets always begin with Amazon -bracket- followed by the other identifying characters you add. So you see how it has Amazon dash bracket dash there?
Yeah. Okay.
It didn't work until I did that.
Okay, that makes sense. All right, cool. Okay, well, thank you.
Send you that. I'll send
Yeah,
you-
no, it's good to know.
Through a couple of lines like you are seeing here. And I will show you how you can navigate to the bucket from the Braket console to check the results of your tasks. So I have executed some tasks before, and I will show you how you can.
So she executed the task before,
Management console.
and she's
You
showing to go to tasks.
to the tasks option,
Yeah.
and then
a completed task with the results in it, probably.
Or here with a different status, if they are queued, if they are being executed, if they are already completed. Here I have some completed tasks. This one was sent to an Ion QPU, but I will show you that I also sent some tasks to a Rigetti QPU, and that one is associated to a different AWS region. So in order to see that one, I will need to navigate to Northern California here. And okay, let's just wait for a few seconds, and then it will show me all the tasks that I have sent to the Rigetti QPU before. So if I want to check the results of these tasks, I will just go into the detail here and navigate here to the link to the S3 bucket.
Oh yeah. And
Okay,
the
yep.
link to the
Yep.
result.
Yep, she's going to the S3 bucket, which I presume she's about to click on. And she is, it's just loading up.
Braket console, and then
There's a JSON, the results come in a JSON file, it looks like.
the execution of my
Yeah.
circuit.
52.8 kilobytes.
To access the results of your tasks. And well, finally, I skipped this option, which is the jobs option. And we recently released a capability in Amazon Braket that is called hybrid jobs, where you can combine classical CPUs with
Oh, that's interesting.
in a single algorithm. So you will be able to execute different parts of your algorithm in classical machines or in quantum machines. And
Yeah, so if a okay.
that kind of
Probably a
jobs
cost savings
from
thing.
this option in the management console, and Braket will be in charge of everything behind the scenes. So you won't have
So it's a different type of hybrid job. Just
classical virtual machine to execute that part of your algorithm, or checking, for example, the creating the tasks manually for the QPUs, because all of that will be done behind the scenes by Braket. If you specify
Oh, you don't have to
your
determine it?
algorithm and your
It,
code
it
here.
figures it out.
So I want
it'll
to
be
show
determined
you
behind the scenes by Braket. Yeah.
able to check that in a different video, but
Hmm.
this is the part of the management console where you will be able to access
That's interesting.
new feature.
Yeah, that's it.
So this was our journey in the
All right, and
Amazon
thank you.
Braket management console. I
Yeah.
hope you enjoyed it, and I hope you continue learning.
Enjoyed, I did
about
enjoy.
quantum
So I got some
computing
questions.
at AWS.
I waited till the end.
Thank you very much.
Yeah, let's ask her questions. What was her name again? Did you catch it? Vanessa Hernandez Mateos.
Yeah. So a couple of questions.
Yep.
Sort of went over it in the video.
Mm-hmm.
What's a simple circuit?
We're gonna skip doing actual tutorials today,
Okay.
and then so what I'm gonna do is, but in keeping this will be our third video in a row where we use ChatGPT, just because to get it to describe to us what a
No, makes sense.
quantum circuit is in like we're a 5-year-old. Okay. I'm gonna type, please explain to me what a quantum circuit is, like I am a 5-year-old. Okay, let's pretend you have a toy box with different colored blocks. Each block is a tiny piece of information. A quantum circuit is a set of instructions that tell those blocks what to do and how to change from one color to another. Just like when you build with blocks, the instructions you give determine what the final toy will look like. Similarly, the instructions you give the quantum blocks will determine what the final information will be. Quantum circuits are used in a type of computer called a quantum computer, which is special because it can process many things at the same time, much faster than a regular computer, just like you can build many toys with your blocks at the same time. So it's basically, do you get that analogy?
Yeah, yeah.
Okay. Now, like, I'm a 10-year-old. Sure, let's make it a little more advanced. A quantum circuit is like a recipe for a computer to perform a calculation using quantum bits or qubits for short. A qubit is like a regular computer bit, but it can be in many states at the same time. This allows quantum computers to perform many calculations at once, which can make them much faster than regular computers for certain types of problems. In a quantum circuit, we use gates to manipulate the qubits and change their state. Gates are like tools in a toolbox, and they perform a specific operation on the qubits. For example, there might be a gate that rotates the qubit to a different state, or a gate that measures the state of a qubit. By connecting these gates together in a certain way, we can build a quantum circuit that performs a calculation for us. Just like following a recipe, if we follow the right steps in the right order, we will end up with the right result. So a quantum circuit is like a set of instructions that tell a quantum computer what to do with its qubits in order to solve a problem.
Well,
That
I
yeah
understand that one more than I would have understood it without doing the first one.
yeah, isn't that funny? So now tell me what it is like I was Einstein.
No.
We're not going to do that. Yes, sir. So I don't know. Without further ado, we are sitting at 22 minutes. We could just consider this video a review of Vanessa's video. Thank you to AWS for making this video. This is from reInvent from earlier this year or late last year, I guess. So I appreciate the 10-minute tutorial. Once we get a bracket a little more figured out, we will probably come back with a tutorial with yours truly and his truly doing the 10-minute tutorial with the various actual quantum computers, because machine learning is cool and we love the cloud. Hey, we forgot to mention like and subscribe to the Cloud Brothers. And we're if you're looking for cloud people,
Yeah.
we're right here.
Contract work.
Yeah.
For cloud.
We will work for cloud. And Scott is actively entertaining offers. I am inactively entertaining offers. You know what I'm saying? All right. Okay. Thanks for watching, and we will see you in the cloud.